This is RPA 7, which is about reaction time. It's not a very complicated one at all. It's pretty short, really, but we'll go through some of the bits. So this is the one where you would be dropping a ruler and catching it and using that to measure reaction time, usually with a bit of a formula that you put in there. Now, really, I think the two things to concentrate on this one are it's a good experiment for exploring doing means. So in this, somebody would drop the ruler and you would catch it over many times, and it's quite a straightforward one to do. So you will end up with several readings, maybe 5 or 10 or whatever it may be, and you would have your reading in whatever it was you wanted to measure it in. Worth noting here, it's a slightly odd table because normally where we might think the independent variable would go in the first column down, here it's usually shown as saying the try, or the number of tries. Now our units, actually our standard unit for distance is meters. Okay, you might put it in centimeters or millimeters and say that is a higher resolution, because if we measure something in centimeters, millimeters would be a higher resolution. It means it goes down to a smaller gradation. Okay, but you're not always justified in going down to the smallest resolution. You might think it's going to be the best thing, but if there are enough errors in the experiment, and there will be quite a few errors in this experiment, as we'll see in a second, we're not always justified in saying, yeah, I can measure the distance to the exact millimetre. So it could be things like, am I measuring it from the very top of my hand? Am I measuring it from the middle of where I caught it? Am I measuring it from the edge of my finger? All these kind of things. So we're not always justified in going to the highest resolution. So let's say we caught this. I'm going to measure it in metres because I am. And let's say we got something like, let's make some quick numbers up. There we go. Now, if I wanted to do a mean average of these, and of course I do want to do a mean average, remember that the thing to do with it would be to add the numbers up, 0.2 plus 0.32 plus 0.2 plus 0.25 plus 0.18. Now, before I do this, it's worth just making a quick estimate and thinking, where is this number going to be? My highest number is 0.32, my lowest number is 0.18. Somewhere in the middle of those is going to be in the mid 0.2 somewhere. So if I get a value either above my highest or below my lowest, I know I've gone wrong somewhere. So add them together. I would always suggest doing it this way. Press equals at that point, then divide by the number of things you've got. Okay, and there's my mean value of 0.23. Okay, the reason I say that, if you go plus divide by 5, all it does is it divides the last number by 5 and then adds all the other numbers on. If you remember your bid mass, what it'll do is do the division first and then add them together. So make sure you press your equals. It's a common mistake for people to make. Okay, what's the benefit of doing a mean? There are two things really. One, it can reduce the effect of what we call random errors. Random errors are mistakes in our measurement that we can't really avoid, we can't really control for. So, this experiment, although again it's fairly straightforward, we might get little problems such as maybe we didn't quite get the top of the ruler lined up, maybe our hands were slightly differently closed, maybe it brushed against our hand. And alright, we can control those errors to a degree, but I suppose they're not really random errors, but what doing a mean does is it helps reduce the effects of errors, certainly random errors. It can also help you, and this is important, identify anomalous results. And the reason that's important is what most people would put here is that it allows you to spot outliers or to remove outliers or remove anomalous results. And of course it doesn't remove them. All it does is allow you to spot them. If I had a result that was what colour I use, 0.97, I can see that doesn't fit the pattern. I've identified it's an anomalous result, and then I can either remove it or redo the experimental result. So I can remove or I can repeat it. Okay. This is also where we get something called precision. Precise results mean that all of your numbers are quite close to each other. Okay, and these are fairly precise. If we're talking here about the difference in 7 centimetres, I suppose, is the biggest gap, which is quite small. Particularly in things like physics, the precision is often a lot better than in biology, because in biological systems you've just got more potential errors. Things are more varied, if you like. Excuse me. Oh, I should just mention here as well, something else you can do with your results. I mentioned it on one of the other clips. You can work out something called a standard deviation, which is a bit of statistics that you might have come across before. What it does is it tells you how spread out your data is, and it sort of tops and tails it. It takes off the extremes. So any results that are extreme values tend to be reduced by working out standard deviation. And that's a way to clean up your data a little bit. We could also say on here that because we can do this quite easily, we get large sample sizes. And large sample sizes are generally a good thing in science. The more data we get, assuming it's good data, that's going to be better for us. So the fact we can repeat this lots of times makes us more confident that our results will be correct, or more likely to be correct. And I suppose the other thing, really, just the last thing to mention for this experiment is the excuse me, the large amount of human error that can go into this. So, when we're dropping these things, perhaps we give a little signal accidentally that's going to drop, and all these kind of things are cleared up by not having a human drop it. If we had some kind of robotic claw that dropped it and didn't show anything that was going to drop, that would make things a little bit easier for us to be more confident in our results, that it's not some kind of human error in the way we drop it, one of these random errors that we can't really account for. So that's reaction time. There's not a lot to it, but I think the questions I'm more like to ask are things around calculating means, precision perhaps, and this idea of why we do repeats. What's the point? It's to identify anomalous results. Oops, I forgot to put results on there. Identify anomalous results, and to remove the effect of random errors. We reduce their effect.